recording. Cool. All right, so first thing on the agenda, download Python. Download Python 3. So when you open it, you basically get an installer that just is the usual, like next install. Don't do that. Do not just randomly click next and install the thing. The reason for this is, all right. Oops, I do want to cancel that. Don't do that. The reason for that is there is a checkbox on there that looks like, I'll actually uninstall it and reinstall it just so you guys know how this works. There's a checkbox on there that says add to path. That's a super important checkbox because if you don't do that, when you try run commands in the command prompt, so like the terminal, it will not work. You type Python and nothing will happen to be like, I don't know what the hell you're talking about. Don't be like that, don't be sad. It takes like a few minutes to fix and it's not very fun. It depends entirely on the computer you're using and it's just much more annoying to use. So while everyone is doing that, I'll just walk around, make sure everyone can do it. Just go through your installers and then there will be a third checkmark box that says add to path. Good. Okay. You already have Python, so you're good.
It's just like install.
So put customize.
I think it's like on this.
Oh yeah, that's fine then. You can just put this all in with this next one. Downloads. You're missing A and S. You're fine. So if you did that, cool. Install now. There we go. Yep. Same thing. You already have it all working. Cool. That makes it weird. Now everyone's installing things. Cool. You got the checkbox checks. Oh, that's the other one. Okay, cool. I said, if we had not done that, we would not introduce Richard.
Guys, because you know we're just going over and selling Python and stuff.
Got it? Okay, so you're on Mac, so it should be a little bit easier. So continue. And then everything's checked. Should be good. So yours, see, Mac's a little bit easier. It actually automatically adds in, or it should. But if it doesn't, it's right. So what's really? So for the sake of video clarification, you just double click it, open it, add Python 3.6 to your path, and then click install now. And then just wait as it does this thing. Now, if everyone, when you're done, can you do the usual to open the command prompt, which is either if you're in Windows, just the Windows button and then R and then type CMD, press enter. So I'll do that again real quick. Windows button R, type in CMD, click OK. It should open the command prompt. If you type in pip, which right now mine is not working because I literally just uninstalled Python and I'm reinstalling it. If it does not come up with anything, if it says that same error, which will be this, if it says this, pip is not recognized, you have an issue. And that's because pip did not install when you install Python. There is a way to fix this. It's very easy. It's actually, there is a right here. If you just type in this link right here, which I'll actually move down to the next line so it's easier to see. If that doesn't work, this link, it downloads you a script. Just double click it, and it should run. It should install pip for you if it does not work. So we'll go around and make sure everyone's pip is installed. Just waiting on mine as well. Yeah, once it's done, I would honestly click that just in case. It's not that big of a deal. And then yeah, you can just close it out. So it just say add save path. That's really not that important, but just that helps you in the future. So, yeah, and then you'll be done.
You said it doesn't.
So if you have to restart your terminal after you've done an install, it reloads all the stuff in the path file, and then you type it.
Braxton,
what's up?
So apparently they renamed this Python to just be Pi instead of Python. That's just for Python 3. Python 2 is still.
But mine worked earlier. I literally tested this before I came here. And
I just installed it, now it's Pi. That literally makes no sense.
I just ran Python works on mine. Wait, maybe it's the 3.6. I just ran. I ran it on 3.5.
Mine was 3.6.4. Well, mine was that.
I mean, this is also free.
Doesn't really matter as long as it works as somehow. Is everyone's working? Does Pip work if you've installed it already? Yes, if it does a huge dump of text, it works. It's working? Oh, it's still solid? Okay. PIP.
It's not working.
Not working?
Did you? Okay. Oh, so you don't want to.
Yes, loading. And then, okay, so then go to the link that I have there, which I'll re-put up there while I walk around. So just as a reminder, if you type in PIP, and I will actually make this bigger so you can also see this, font 28, there we go. All right, if you type in PIP and press enter and it says it's not recognized as an internal external command, or on Macs it literally just doesn't do anything, that's bad. So we're gonna go over to how to fix that in a second. This is the link for that. So all these are all the things that you'll need to get. If you wanna go ahead and get Sublime because you're done and everything works perfectly, go ahead and get that. But right now we're working on this step right here. Just ask us if you have any questions. All right, yours good? Getting everything working? Okay, just make sure. Should I, while I'm here, I'm gonna make sure. What's up? Still not working, even after running the thing? Huh. That's a weird problem. It might be like yeah, there you go. Okay, so if you're on Mac, it might be PIP3 or PIP3. Just because Python 3 changes everything because it has to work with Python 2 installed and nonsense like that. So if PIP does not work, I'll go back here. It might be PIP3. Mine doesn't work because I haven't restarted my terminal yet, but just check all the things. It will either be Pi, which mine does work, or it will be Python, which apparently, yeah, it is Pi. I don't know why it's PY.
So, what's like, I get like a list of commands.
Yeah, as long as it dumps like a bunch of text when you type PIP, that's good.
Nothing after that.
Yep, nothing after that. The nearest outlet? I thought it was setting my filler, but I guess not. There's some on the wall.
Come with us. We have small batteries and a plug over here.
There are small batteries in the wall, so that's good. I'm sorry. Alright. Is anyone having problems?
Did you say restarting my?
So if restarting the computer is not really the thing you want to do. You want to just close your terminal and then reopen it. So like actually just like close all running versions of CMD or whatever your Mac terminal is, and it should function when you reopen it. See, mine is just taking 6 years, then it dumps a whole bunch of text. Anyone? Oh yeah, links can go back up. Sorry. Ta-da! Alright, you guys good? It's all working? So just type in the command prompt, keyboard. So like keyboard, and if it shows up as Python, that's good. If it shows up as any more of it after the keyboard away. Now, if it does work, it'll be in the menu. You might have to type in exit. Or you close it. I mean, that works. That also works. Alright, anyone need help? Everyone good? What's up? Recording for not streaming. I can, but I don't have everything set up, and I don't even have the mic to send in. Like, I'm not gonna do that right now. But I will just And then just go to wherever you want to that you think is a good place for stuff, and then save it there. Now go to that folder and then run it. So you can just click it in there. It should run. If it doesn't run, let me know. So you guys are all set up with Python and Pip works? Awesome. Oh, Richard, did you have another question? I'm sorry. I failed you. You're smirking? Yeah. What's up? You're really good. Yeah, I think so. It's okay, I'll talk about it. So exit that. So type in exit. So yeah, it's open command. Right. It looks like most of you are done, so go ahead and download Sublime, which is the top link up there. If you guys don't know, Sublime is a text editor. Basically, just think of like Word, but meant for like, this one in particular is meant for programming and just like other file editing purposes. Way less bells and whistles, but it is way cleaner and it's really nice to write your code in. It doesn't have anything fancy like an IDE, but it's just super slick, super fast. It's really nice. And that's what I'll be using today. So all the shortcuts and everything that I use will be the exact same. But yeah. What's up?
So we just go under like the download. We don't go to change that, right?
Yeah, just go ahead and download the Sublime Text 3 version that you see. It should be a-okay. I don't think I've never had a problem with Sublime, so hopefully we're right. What's up, man? Yeah. Did you close it and reopen it? Okay. That's interesting. So Python, yeah. Interesting. That's a weird pair. Everything default? Or did you install everything default? Or did you use for yeah. So it's about is everyone good? How it's setting up? Just make sure. So there you go. PC should be at the same time. It should say was it? Yeah. Oh, did you install one here?
Yeah.
So can you cancel that? You need to right click the there you go. Now edit. Cancel that. So do it out to interesting. What's up? Yeah.
Hey guys, thank you for coming to Python Bootcamp. I'm really sorry I didn't have the check-in set up throughout this whole time. If you could, one by one, or so you can see the tutors open, check in so we can make sure this happens every year. Yes, and we also have donuts. So if you're just sitting around waiting, you can come up and grab donuts.
Sorry about the issue. Alright, taking a break to change my microphone. Oh man, I'm so quiet. And is that better? I actually don't know. Well, it says it's in the green and no longer in the you know, terribleness. But I might bump it a little bit since it's not anywhere near what we had earlier. Cool. Alright, cool. Oh, and then I have this up, so that's gonna be annoying. Oh, I'm recording this session. and everything's going good? Everything's going good? Anybody not working? Everybody is currently working. If you have not gotten food, go ahead and do that. If not, or if you're good. Wait, what? There's no donuts? No more donuts. I didn't even get a donut. 10. Anyways. Hey. I'm okay with that. All right, so we're gonna go back and we're gonna start working on actual like Python shenanigans. Hey, Brian. Come over here. What's up? So Sublime is the text editor I'm using right now. This is like, it's just the best thing. It's super simple, super sleek, but it's like when you write an essay, you use Word. When you write programs that don't have like an IDE like Java does, Python or Sublime is like really, really nice. So most of our code that we write today will be in Sublime, or actually not most of it. We'll actually be using Ripple for a good bit, but. If everyone goes back to their command prompt, which if you don't know how to go to, if you're on Mac, it's a little different, but just open your terminal. So it's Windows button, and then R, and then type in CMD, press enter, open this. So what you can do is if this works, if you type in Python, or whatever works for you to open Python 3, so not Python 2, but Python 3, type that into the terminal and press enter. And so right now, that'll enter you into this state right here. And you see those like 3 little greater than signs? Well, that means you're in the Python RPL. The Python RPL is basically like a test bed for Python programs. So if you type in anything in here, this will be interpreted as Python commands. So like whatever you, like you know when you type in Java programs, you'll be like, this variable is blah, blah, blah. Well, if you type that in here, it'll work just like that. So I'll go into a little bit more detail as we go along. But the idea is you can put in anything in here that you want to test out really, really fast right here. So if I want to say, talk about variables real quick, I can say the letter X is equal to 5. So if I press enter, it doesn't do anything because I just said X is 5. If I type in the word X, it'll actually print out its value, which is 5. It's super fancy. Anytime you do anything that returns something, it will print it out. So if I say like something is a string, something's a number, whatever, that'll print out as that on the next line. So you won't have the little ripple; it'll just be right there. The same thing can be accomplished with a function called print. Print will be your best friend whenever you're learning how to program because that is how you debug everything. So whenever you type in print and then put in parentheses, you can put whatever you want in here, like quotes, hello. And then if you type that, it'll actually print out hello. Now you can do the same thing if you just do this, but this only works in the RPL, not elsewhere. What's up?
So how similar is this language to Java? It's like it's
So Python is, so I was just about to talk about that. Python is very syntax lenient. And when I say that is, you know, in Java you type in and you're like, okay, you want to do your main function, you have to have the curly braces and the strings, args, all that sort of. No. Python doesn't mess with any of that. Everything's done by indentations. So if you want to have like an if block in Java, you have like your curly braces and whatever's between those curly braces and that if. Python works as if it's indented, it's part of that segment. And I'll show you an example in a minute, but it's actually super light. There's not a lot of syntax. You don't have to say, like, if you notice when I said like X is 5, I didn't have to type its type. I don't have to say it's an integer. I don't have to say it's a string. It just knows. It's good. It's super friendly. What's up? Did I see a hand back there? Oh, okay. So we'll talk about some other variables. There's a few other different variable types. So you can put like X is 5.5. And if I type in X, it'll be 5.5. There's another function in there, just like print. It's called type. Type will say, okay, if you pass in whatever variable it is, it'll actually give you what it's called. So if I type in there, it'll say, oh, this is a float. If I make X 5 again, and I say type if X, it will say, oh, that's an integer. Ignore the little syntax. The things in the little single quotes is what we're looking at. Is everyone like good right now? Just entering some random commands and it kind of working, kind of not. Things will always break. That's the expected thing of Python in literally every language. But so the other cool thing is obviously it's keeping track of what I say. But if I want to have like y is like 11, if I say x plus y, it'll actually print out the value. Now this doesn't actually work when you're writing a normal Java program. You can't just say x plus y and it print it to the screen. This is a special RPL thing. But if I want to say x is x plus y, it will now say when I type in x, it'll be like 16. Because the old value of x was 5, the value of y is 11, 5 plus 11 is 16. It stores that into X. You're good to go. This can be done with a lot of different things. Just like in Java, you can be like, I want this string hello to be added to another string called world. So if you put those in quotations and add a plus in between them, it all become one string called hello world. You can do that same thing of typing if you want to check. If I want to say, what is this? It'll tell you it's a string. That's the nice thing about Python. You can literally check anything. But notice how, when in Java, just like in Python does the same thing as Java. If you try and add like a string, so if I say x is hello, and I say y is 1, well, I can't do x plus y. It does not like that. Strings and integers are not the same, right? But notice you didn't have to check it. And regularly, before you compile a Java program, it'd be like, hey, you can't add strings and numbers. That's not right. Because I don't know what to do. Because I don't know whether to take this as put the number at the end of the string, or try and add the string's characters to a number. It gets confused. Well, Python, it doesn't do that until it actually tries to run it. That's what Python is. Python is called an interpreted language. So an interpreted language is, it doesn't do any, there's no compiling. Whatever you write, it tries to do, no matter how broken it is, no matter how wrong it is, it'll try it. So if I say 5 plus hello plus 6.6 plus world, it does not enjoy that. And the main reason is you can't cross type like that. If you ever want to add a number to a string, there is another function that we talked about earlier, other functions that you can do. You can type in 5.5 to this function. It'll return in quotations 5.5. So it just stringifies everything. So now I'll actually just move on to some cooler things that you can do. Which mainly I just want to make sure I don't skip anything. So I have an agenda. All right. So we've got a few things. Python, just like Java, it'll have, if I want a character b, or the variable b to be equal to true. Now, notice I had to put in a capital T for true. Java does lowercase. I think Java even supports multi-character if it's uppercase or lowercase. It doesn't really care. Python cares. It has to be uppercase true or uppercase false. So otherwise it does not like that. So if I go b, it'll say true. If I say b is false, b is false. Cool. If I say type of b, it'll say Boolean. So it's just a yes or no, true or false. And Booleans are great. Booleans are great for logic, mainly because if I want to say, hey, are you correct? Are you done with something? Or have I done whatever my job is? Booleans can hold those values while being really, really small. And they're also pretty, Python's really easy to name stuff, so you can do literally anything on the fly. So now I'll make sure I don't skip anything else. We'll talk about Unicode and objects later, because that's a more important thing when we get into it. But mainly right now is just using the REPL is one of your most the easiest things in Python. If you ever want to be oh, I wonder if this will work, you just go up to your computer, type in Python, and then run your code without having to type anything in a text editor, and then press save, and then compile it and do all that shenanigans. If you want to test something real quick, you just want to know if it works, REPL is awesome. So when you're using the REPL, just remember, anything that you've entered before will be stored. So if I say x is 1000, it will be there until I leave the REPL. So if you're ever coming into issues with a big program in the REPL, you're not really supposed to use the REPL for a big program, because you might do the wrong variable or whatever, and it'll remember it, and it just gets really, really messy. So just use this for short-term things. You can do all sorts of crazy things. You can do a lot of concatenation, like hello, and then plus world plus str of b. I don't actually know if that works. Oh, it does. So it'll put out a huge just chunk of information. All concatenates the same. Everything just gets appended one after the other. The minus sign does not work. Don't try that. It's only the plus button, or only the plus symbol. So basically that is called concatenation. It's just putting one thing at the end of another thing. So if you notice how I have x is 1000. Can you guys see this, by the way? Is this all really visible from back there? Okay. So if I have x is 1000 and what? Did I hear something? Okay. And y is 100. If I do x plus y, I'll have 1100. But if I do string of x plus string of y. It will do the normal actually adding one thing to the end of another thing. So that's the difference between concatenation and just the regular add command. It has the same symbol, but they mean very different things for different like types. Python's really simple, so if you ever get confused about something, using the type checking like feature is really handy. Now normally when you're in a program and you want to do that, you would type print and then type of y, right? So that'll do that. And what I did right there is something fancy. It's just like nesting function calls. Not something super fancy you guys need to know right now. But it's basically, if I want to call a function, I can use what it normally return and put it in another function. So if I say type of y is an integer, right? Okay, well if I say print y, it'll just print what the value of y is, because if I type in y, I'll just say 100, right? Well, I can say, okay, I want to print the type of y, and just read basically like English, and there you go. It'll do exactly what you asked for. If you ever have any errors, so notice if I do 5 plus hello again, it'll actually give you, Python's pretty helpful, it'll tell you almost exactly what's wrong. There's no pointer exceptions. You don't have to worry about that from Java. It'll actually say, okay, this is unsupported. We can't add an integer in a string, just like I talked about earlier. This happens with any other thing, so like a Boolean. So if I say b plus hello, that'll probably say the same thing. Yeah, you can't add a Boolean in string. Does not work like that. Pretty basic stuff with programming. So let's move on to some cool things that are a little bit nicer. Yeah, we'll go into conditionals. Now conditionals, these are the things, this is how programming works. This is the very like basics of programming, and this is super powerful. And this is basically where you do a branch. If I want to do one thing or the other. If I say b is true, capital T. If I say if b, and so this is, notice how my syntax here is if, and then I put in what I want to check. No parentheses? Oh, does that not work? Oh, anymore? Oh, okay. Excuse me, I'm learning bad habits. If b, don't need parentheses, I'm a liar. If b, and then you do a colon. Now what that colon means is that whatever I'm going to say next, well, you can do. And now you have to press tab. Tab is the indentation. So in Java, I mentioned this earlier, in Java, the open curly braces is how you know stuff goes inside of a section of code. So if I say if, and then curly braces, whatever happens between the next curly brace will be done by the if statement. In Java, or in Python, it's if colon, and then you tab over, and then whatever is done in the tab, it will do. So if I say print x, and then I press enter again, it'll be like, oh, you see the ... you're not done yet. Not until you press enter on an end line for the ripple will it actually leave. And then if I say print y, and I'll press enter again, press enter, it'll print the value of x, the value of y, and then be done. Now if I say if not b, so notice how unlike Java you don't have to use the exclamation point, you just say if not b, do a thing. Notice how it doesn't do anything because I pressed enter and b is true, so it's not gonna, it's gonna say if not true, which is that's false. It's not gonna do anything. So now we can actually yes, this is, so Brian is on the board writing basically what the equivalency is in Java. So in Python it's if true, print hello. In Java it's if true, open parenthesis, or open curly braces, system.out.println, whatever you want, close curly braces. So Python's a lot cleaner, it's like a lot shorter, a little bit easier to read because notice how not is in plain English, there's no exclamation points, it's not weird symbols, and is not something you use, you just use the word and. It's really sleek, really simple. So for the rest of this, like it's all about just using the ifs, ands, ors, whatever. Now I'm going to talk about the or stuff in a second, the and or. Let's say we have a Boolean, didn't have that clicked. So we have B is true, and A is false. So we're going to say if A or B, Brian, I like this. If A or B print something was true. I know, right? Really original. And you press enter again, something was true. Because if you look at it, what I passed into the if was essentially, if you're thinking about this in Java, it's whatever is in those parentheses and the and stuff. In Java, or in Python, you look at whatever is in this section right after the if. Well, if we look at A is false. And we look at B is true. So it goes, okay, well, A is false. Let me look at the next thing. Well, B is true, so I go, okay, conditional passed, I'll do whatever I said to do. Now, if I do something the same thing, if I say if A and B, and then I type in print both were true, press enter again, nothing will happen because because A was false. And that means and is basically everything that I say and, they all have to be true to actually pass. And the reason for this is, if you look at A and B, notice how it already checks you for it. So that is like, it's kind of like a secret function. If I say A and B, it takes the thing to its left, thing to its right, and goes, okay, are these both true? Return true if yes. Are they both? If either of them are false, say false. And that's what that did right here. It's basically like a sneaky thing. So you can say y equals A and B, and then do if y, and then do your stuff again. Yes. Notice how it doesn't do anything because I just stored the value of what I had earlier. So that's some basic conditional stuff. You can do that with or. Not does the same thing. So if we already talked about not, but like you can do that in the whole section. So if not A and B, print hello. So notice how if A and B return false right here, right? Well, A and B is false, so if I put a not in front of that, it's going to negate that. False becomes true. If true, do the thing. So there's some basic conditional logic in programming. Now the nice powerful thing about this is, let's say I either want to, if I'm given a number, and like I'm making a basic calculator, if I'm given a number and I say, okay, this number has to be less than like 10 digits long, I can check that, and I say, if that's true, it's less than 10 digits long, do your addition. If not, I can say, hey man, don't do that. Print like an error message, or just crash your program, or whatever crazy things you want to do. That's just like the basic functionality. Some other things we want to talk about are implementations. So implementations, so basic ifs. There's some other like looping things. So looping is a really strong technique in like all of programming. Looping is how you do something repeatedly. And obviously you don't want to just copy paste your code like 1,000 times to do something 1,000 times. You just want to do, okay, I want to do this at least 1,000 times and then print out yes. Who knows why you want to print out yes 1,000 times, but you might want to. The way we'll talk about this is just for. And for is a super strong, like super strong word. And the thing is, it's totally different than Java's for. The reason for this is, in Java, you do for, open parenthesis, I'll type it in Java real quick. For int I is 0, oops, that's wrong. I is 0, I is less than like x, because we had that as like 1,000 or whatever, I++. That will do it something, however many times up to x, right? Well, in Python, it's totally different. There's no such thing as an iterative loop like that. There's actually only for each loops. And I don't know if you guys are experienced in Java, but for each loops are basically going for something in a list or something in an iteratable section, do this many things. And so we'll talk about that. So if I have a list, you can make a list like this, just brackets, just like you would in Java, but I can actually put in its values just 1, 2, 3, 4, 5. Right? Put it like that. So if I have let's say the li is our list of 0, 1, 2, 3, 4, 5. We can say type of li, and you see it says, hey, this is a list. I can do things with it. The nice thing about this is if I want to go through each item in a list, normally you have to be like for int I, and then I set I to 0, go through the length of the list, or just use a for each loop in Java. Well, in Python, it's super simple. You go for, you name a variable that you want for the value of the iterable item. So you want to say, let's say number. For number in my list, li, we'll say print none. Or it has to be right next to it, I think. So, okay, press enter. It'll go through 0, 1, 2, 3, 4, 5. Bob's your uncle. So lists do the same thing as just like in Java. They start at 0. So let's say if I do li of 0, you'll get 0. If I do li of 0 equals 1,000, it'll store that. So if I say li of 0 again, it'll be 1,000. If I run this beautiful for loop again, print number, it'll print 1,000. It stores it just like in Java. And so now for loops are basically a way of doing whatever you want to in a for each manner. Now there's a cheaty way of doing an iterative number, so from a number from 0 to 1,000 or whatever you want to, like Java. It's not recommended, it's not good practice, but it works, and sometimes you just need to use it. So the way to do that is, so for num in range, and that's a function, it's another function just like we had print and type, and this will go for range, and you can go through 0 through 1,000, and then print. No. Oh no, that's gonna be too big. I'm gonna do it anyways. It works. See? So it goes through it now. So the nice thing about Python though is that what it returned in that range function is an iterable. It's not actually a list. It's just saying I'm gonna give you a thing that goes from 0 to 1,000 that's not actually all those numbers, so it doesn't have to store them. It's really, really handy. It's kind of like a little special thing, but whenever you say, if I say li is range of 0 to 1,000, if I say type of li, notice it's no longer the same. It's not a list. So that the big distinction. The range function does not give you a list. It gives you something called an iterable. In Python, basically that just means something that goes, it's kind of like a linked list. It goes from one thing to the next thing to the next thing to the next thing. It's super, super different, so don't try and like use them the same way. If you need to make a list of numbers from 0 to 1,000, make a for loop, do it in the range of that, and then put your numbers in the list. Sound good? So yeah, now I've just destroyed my list, so I'm going to restore that. 1, 2, 3, 4, 5. So now I can do some cool things with lists. Just like in Java, there's like there's a set of commands you can do. So if you do li dot, the dot says I'm going to use a function of this for this object that I have. So li dot, isn't it append? Pretty sure it's append. If I want to say append 5, and I go li, it's going to go 1, 2, 3, 4, 5, then 5. So append always adds something at the end. Lists also have another thing. So just like in Java, unlike Java, lists in Python are much more versatile. So when you usually make a regular old list in Java, you have to say, okay, like list, or I don't remember the exact syntax. List li is, oh wait, no, that's different. Yeah, type int li is, yeah, and then you say like 1,000 if you want 1,000 spaces in your list, right? For Java, you don't have that. There's no size restriction, but there's also makes it a little bit slower. So it's infinite space up to your memory limit, of course, and you can do whatever you want to. So you can do li.append. You can also do li.pop. So what pop does is just like in stacks or queues or anything like that, if you're used to those data structures in Java, it'll remove the last thing in the list. So it'll remove the last thing in the list and return it. So I can just say li pop. Now notice it printed 5. That's because pop returns the thing that you just removed. If I print li again, it'll remove that last 5 that I just added onto it. You can do other things. You can do li dot, what is it? You can do pop the number. So if you want to say, okay, I want to pop the first thing in the list, I can do li pop 1. Notice how it pops the 1. Print out li again, 2, 3, 4, 5. Sound cool? All sorts of crazy cool things you can do with lists. The nice thing about it is there's a lot of really, really cool documentation for Python. It's really, really well done. I'm also in Python 2. That's wrong. Just Google. You can just Google Python 3 documentation. It'll be here. And it tells you literally anything you want to do in this language. Here it is. It's only how to use the built-in functions and data types and stuff like that. It won't give you examples on how to build a video game. But there are things like that are related to that are tutorials for how to build video games. So everything's on the internet. Definitely make use of the documentation. It's super, super useful. Most of the things I just talked about are like built-in functions. So like I can say range was a function that I just used. str was a function that I used, and a few stuff like that. Let's talk about some other stuff. Another data structure in Python that is super, super useful is a dictionary. A dictionary is basically, it's a key value pair, and this might sound like a bunch of gibberish, but basically that's saying I want one thing to map to the other thing. So when I ask for this one thing, or if I give you this one thing, like the key, I want to get its value. So I can map anything to anything. So if I say di is dict, so if I say di, it's going to be an empty curly braces. Curly braces that's how you know it's a dictionary and not a list. Dictionaries are super, super fancy. So if I say di, and so instead of saying an integer number or whatever I want, I can say a key. So if I say key for here, and then I give it a value which can be like 5, if I do di, notice how inside of it is now saying the key is mapped with a little colon symbol to 5. So if I ever go di of key, it'll give me 5 back. The nice thing about this is you can have it any set of types mapped to any set of types. Is that not the same?
You need to be able to hash the key.
Oh, right. Basically, you can map any one set of type to any one other set of type. Excuse me, you got a question?
Can you store a list as an element in your dictionary?
Pretty sure, yes.
You can store anything as a value, but you cannot necessarily store anything as a key.
Yes. So basically, you can say, di of key.
So a dictionary, in its essence, it's called a hash table, and what it does is it takes the key value and then it hashes it as a part of the dictionary, and it needs to implement a certain kind of function within its class in order to be able to be a key in a dictionary.
So basically, what that means is whatever number or whatever thing. So notice how when I say di of this part right here, this big old string, that thing has to be very, very special and has to be able to map in a one-to-one function, basically. So if I have whatever I enter has to be able to give me a unique number or a unique representation, so that way when I enter something, I can't have two different things give me the same value. That should never happen. That's why they're called keys, because a key should only be able to open one lock, right? Well, there's some master keys, but ignore that special case.
You can think about a dictionary as a literal dictionary where you have a key and a value where the key is actually just the word and then the value is the definition. So if you want to look something up in a dictionary, you go to the key value, so like representation, I can go to the word and the value is like, okay, that's the definition. So in this case, the key obviously is key and then the value / definition is that array.
So yeah, notice how I have multiple types in there. So I only have one type for the key, but I get multiple types for the values. So I can store list as a value for one of them. I can store hello, which is a string, as a value for one of them. I can store numbers as values. It doesn't matter. But the key is special. It's usually a string. Try and stick with strings. They're a little bit easier. Otherwise, you have to make your own shenanigans. But the great thing about dictionaries is they're really, really fast. I don't mean iterating over them, because that's what lists are for. But I mean, if I ever want something in a dictionary, or if I ever want something like store it and get it back, dictionaries are like the way to go. You don't have to remember indices. You don't have to remember positions in arrays and stuff like that. Just say, hey, I have a key. I want your name. Give me my name back. If I want your date of birth, I can give the date of birth back. It can be a number, a string, anything that you want. It can be a whole object even. If you know what objects are, it can be even object references. It's pretty great. Dictionaries are super, super powerful. Actually, one of the best things I think Python offers. And they also, if you know what JSONs are, this is completely separate. But if you know what JSONs are, Python dictionaries map almost directly to JSONs. So they're really, really handy. Very, very handy, especially if you're working with APIs for online, which we will be later. All right, so now we've gone through some basic stuff for there, gone through some how to print things. You can print anything. So if I want to print DI, it'll just print it just like we did it when it returned. Now the weird thing is there are very few things you can't print. If I make an object that's another object that I define on my own, which we will do later, it will just tell me blah 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 object is some random hexadecimal number. And you're like, well, why doesn't it have a string value? Because the way these objects are set up, so if I have 1 and I just print 1, the way these print up, these can be serialized in a nice human viewable manner. You have to tell the Python program how to do that though. If you don't, it'll just give you some gibberish, which is basically how that works. Basically, after that, we'll go to some functions. Okay, so leaving the REPL is like the big thing. Now, we know how some basic stuff works in Python. You can add numbers, 1 plus 5. You can print stuff, print some cool things, print X. You can do lists and get all those things. You know how to iterate over lists. The bigger thing now is leaving the REPL, because now we want to make our own programs. This is not really scalable. It's really messy. If I want to go back and find something, I have to like literally through my 1,000 numbers that I did not remember that I had there, anything like that. So it gets really messy if you're debugging. So let's exit the REPL. Everybody, you can exit the REPL by typing exit and then open parentheses, close parentheses. Now I'll just close close the Python, back to your command prompt, and we'll move over to Sublime. So what this is Sublime is an amazing text editor that I really, really recommend. Atom's kind of similar. Atom by GitHub, Sublime by I don't know who makes Sublime, but it's amazing. You don't have to buy it. It will prompt you to buy it after you like save so many times, but just click cancel. It'll nag you every like now and then, but it's totally great, totally worth it. Don't have to buy it. Do buy it though if you ever like use it a lot.
Ask around. There are people who hold a lot of free keys for it to give you the full version without you paying for it.
But to be honest, the full version isn't worth it. Not that it's not worth anything, but it doesn't really provide any more features than a text editor.
Yep. The free version of Sublime is literally like Sublime. It just has the name unregistered on it, and it'll say, "Hey, can you buy me like once a month?" Like every now and then, it'll be like, "Hey, can you give me?" Yeah, it's like WinRAR. You can just go, "No, I don't want to buy you," and it'll just leave you alone for a while. All right, so if you can open Sublime, if you're in Windows, you'll just type in Sublime, and it should just be there. Go here, and if you press, it should be empty. It should be like this. So press Control-N, and it'll make a new document. Now this document is not saved anywhere, so if you close this out, and or your computer shuts off randomly, not close it out. If your computer shuts off, your work will be dead. So if you want to save, Control-S, just like Word. Tell it where to go, and I'll say this is my we'll call it first.py.
Be sure to like change the save location because sometimes Sublime may try to save things in weird places.
Yeah.
Obviously, navigate in your browser and figure out where you actually want to save the file.
Yep. So like go to desktop, go to or wherever you want to do this, and just go to your folder that you want to do it in, and then make sure you name it first, and then add the extension first.py, which is py. And this just says that, hey, to your computer, this is a Python program. So we'll save. And now I have really, really big text. And Anaconda died. Don't do that. Ignore that. So basically, what we're going to do is we're going to actually do our normal thing. So if I want to, I can actually say print 1 plus 2. All right. If you save this just like this, and you go to your command prompt, make sure wherever you saved this file, you navigate in your command prompt to that location. So if I do that right here and I type in Python first.py, that's not going to work because I'm not in the same folder. It's actually in my desktop. So you have to cd desktop, cd to my Python Bootcamp folder, and I'll type in Python, or whatever you use. It might be Python 3, it might be py. I don't know why it's different for everybody, but that's Python.
If you don't know how to navigate the terminal, or if you have any questions, please just shout in my direction. I'll let you know.
Yep.
Should we take a real quick thing to see if we're all caught up?
Yeah. Is everyone caught up? If you're not caught up, now is the time. We're like moving to files, so like this is a little bit different. The RIPLE's its own little experience, but the files are like the important part. Is everyone good? Any problems? Questions are fine. Like honestly, please feel free to interrupt me. Just raise your hand. All right. All good. Cool. We're good. We're done. Oh, okay. Well, it is also 8:30. I'm okay to stay around for a few more minutes if you guys want to ask questions, but like we're almost to our hour. Do you guys feel like keep going, or do you guys want to put this on pause for when we come back? Zero feedback. Perfect.
Please, before you go, if you haven't checked in, please check in. It helps us keep this Python Bootcamp every semester, every year coming back.
Do we need to sign out?
No.
Do not need to sign out. But I mean, hey, if you want to tell us if this was a good thing or not, if I need to slow down, because I know I need to slow down, totally okay. Just any feedback is good. But yeah, we can put it off for the next day.
if it doesn't work, just take it. If you need it to work differently, just either take it on or take it off. Usually, I would say no. Don't use parentheses unless you need to, because parentheses breaks up the whole section of reading like English. That's what Python tries to do, is say just read it as English as possible. So like if parentheses break up, then just because the reason they changed the print function to require parentheses, well, I'm guessing that's the reason you're asking, is because print was an exception, and they're like, no, we don't want exception, we want rules. So making print follow every other function in Python requires parentheses. The reason parentheses were part of weird is this, because Python likes the ability to treat your conditionals, if not this, or if this, or whatever. It's parentheses breaks the flow of things, and the only way you won't use it is necessary. I need to pause this.